Hey ladies and gents, here we go. Section 3.3, a little bit of a review. Solve the linear system and tell how many solution it has. I'm going to do probably, let's see, linear combinations. So this top one I'm going to multiply by 2, so that way everything will cancel out vertically. So see what would happen to it. I get negative 8 there. This is still 4x minus 2y equals 8. So 0 equals 0. There is an infinite number of solutions. There you go. Jumping over here to 2, multiply this top equation by 2. Watch what happens here. You get 2x minus 2y equals 4. You still have negative 2x plus 2y equals 2. So this is going to be 0 on the left side. This is going to be 6 on the right. 0 is never equal to 6, so there is no combination that will work. Thus, no solution. Right? So let's talk about what we're going to do today. Okay, today we're going to be graphing and solving systems of linear inequalities. And it looks like we're going to be doing it graphically. So we're going to graph, how do we graph a system of linear inequalities to find the solutions of the system? That's pretty much our essential question. 2 or more linear inequalities in the same variables form a system of linear inequalities. Okay, so there's a little definition for you. Let's go ahead and look at the first one here with the graph. So I'm going to just graph this one in blue. Okay, y is less than or equal to x plus 1. So I'm just going to graph the line y equals x plus 1. It's a y-intercept of 1, and then it has a slope of 1. So as I graph this, I have a slope of positive 1, so left to right, it's going up by 1 at a time. And that's kind of cool. Now, when I go ahead and draw this, it's going to be a solid line, not dash, because of the equal to. Shading, because it is less than, will be below. Okay, so the shading will be down here. There's my graph of y is less than or equal to x plus 1. Now, the next one I'm going to do in red. Okay, x is less than 3. It looks like a heart. So that means x at negative 3, or I'm sorry, positive 3, I'm going to have a vertical line. If you ever get confused which one's vertical and which one's horizontal, you know, do a t-chart. So if I do a t-chart for this guy, x is always 3. Treat it like an equal sign. Y can be anything your little heart desires. So 3, 0, 3, 1, 3, 2, they're all vertical. If we're less than, that means I'm going to shade the less than sign, which would be over here. Now we all know when blue and red meet, purple is the result. So where the purple box is here, or triangle in this case, will be your solution set. So this in here, any point in here is your solution set. Okay? So let's go ahead and take a look at number 2. I'm going to solve this for y so I can graph it. So right now I have 2y is greater than negative x, or equal to negative x plus 6, divided by 2, negative half x plus 3. So, I'm going to graph this, positive 3. I'm going to go 2 down 1, 2 down. There we go. Okay, solid line. Let's talk about shading. Okay, the shading is greater than, so that's above. So that's where we're going to be at. Okay. Let's go ahead and talk about this one. I'm going to move over to 2x. Becomes positive, so this is 2x plus 4. Y is less than that. So we're going to go up to 4, and then we're going to have a slope of 2. Okay, and that's going to be a dashed line. Shading, less than. That will be below the line, so that will be the right side. Again, where you see the purple stuff, that's your solutions, right here. Okay. Any point that's in that overlapped area will be a solution of both those inequalities. Great. Look at 3 and 4 here. Well, that's nice because, let's see, everything's already solved. This one I'm going to put in blue, so positive 3. Go down 3 every time I run one because that's the slope. Dashed line. Okay. And less than will be below that. So that would be over on this side. Okay. Bottom equation, y is greater than x minus 1, so negative 1, slope of 1. So this is going to be a dashed line, the slope of 1. Okay. As far as shading goes, shading is less, or this is greater than, I'm sorry, y is greater than, so that's going to be above. Again, where these guys overlap, that's where our solution set will be. Okay? Top one, I'm going to solve this for y, so this is 3x minus 12, less than or equal to 3y. So I added this 3y over, I subtracted the 12. And I'm then going to divide everything by 3, so this is x minus 4 is less than or equal to 1. Now it's not best practice to graph this with y on the right side, so I'll flip it around. Notice the mouth was eating the y, so I'm going to keep using the mouth eating the y. So we'll start at negative 4 here, and then I'm going to do a slope of 1. Okay. Shading, greater than or equal to, so greater than it is. Over here, this is going to be 5y is less than negative x plus 20, divided by 5. So we're looking at y is less than negative x plus 4. This is over 5. So it looks like we have an intercept of 4, which is here. It's going to be a dashed line with a slope of negative 1/5. So I'm going to run 5, 1, 2, 3, 4, 5, go down 1. Okay? So I'm going to go 1, 2, 3, 4, 5, go up 1 backwards. 1, 2, 3, 4, 5. So this is a dashed line. Okay? And it does appear to be less than, correct? So I'm going to shade below it. Again, you can see where they overlap fairly easily. That's your solution set. And here. Okay. There comes 5, 6, and then we get 7 and 8 yet. Okay, top equation, y loves 3. So think about it this way. This is a vertical line. Oh, sorry, horizontal line. Y is always 3. X can be anything your little heart desires. So at 3, which is here, we'll have a dashed line. As far as shading, y is less than this. So all the y's that are less than that horizontal line are below. Okay. Let's go back here. X is greater than 1. So it's a dashed line at x is 1. Shading is greater than that, guy. X is greater than 1. Okay. So your solution set is in here. Great. Let's graph this guy. Positive 2, run a 3, down 2, run a 3, down 2. Run a 3, down 2, going backwards. Okay. And this is a dashed line because it is less than, there is no equal to. Less than, here. Okay. Let's go ahead and do the next one. Start at negative 3, slope of 2. So over 1 up 2 every time. Going backwards, you can see that's still on the nice line. There's an equal to, so I don't have to make it dashed, I can keep it solid. As far as shading goes, we will be greater than this guy, so we're up here. set. You probably are getting used to this by now. All in there. Right. Last two for you. And we'll draw some conclusions. Right. First guy here. Oh dear. We don't want 2, okay? I'm going to flip this around, so y will be on the left, x will be on the right. The mouth was eating the x plus 1, so it's going to continue to eat them. So this is going to be positive 1, slope of 1. Okay. So that's going to be a dashed line, slope of 1. Going backwards, same deal. Nice diagonal line. I guess I gotta touch that up a little bit. That looks better. Right, shading. Less than, so below. Okay? Going here. Y is greater than or equal to 0. So that's a horizontal line. Solid line. Okay, if you're greater than or equal to 0, you need a solid line, and we're shading above. Again, if you're not sure if it's horizontal or vertical, by all means do a T-chart. Y is always 0. 1, 2, 3, 3, 0. Bam, 2, 0, 1, 0. So it's horizontal. Solution set over here, or the purple set. Okay. Coming up here again in blue, -3, 1, 2, up 1. 1, 2, up 1, 2, up 1, 2 up. And I follow the same pattern going backwards. Dashed line it is, because there is no equal to. And then let's get our highlighter going. So less than, points that are less than or below. -1 is here, slope of 3. And it will be a straight line with solid. Okay. As far as shading goes, we are greater than, so we are actually above. So this is kind of the oddball of the bunch so far. Solution set is barely on your graph here. The solution set is right here. So there's basically an examples with graphic inequalities. If you have a greater than, you shade above. If you have a less than, you shade below. Dashed lines, or if you don't have an equal to, so these get, okay, switch colors. Dashed lines, and you graph them. If they have equal to's like these two, these are solid lines. Okay? These are greater than, you shade above. And the less than signs are facing the other way, so we would shade below the lines. Hey guys, if you have questions, again, email me, find me, ask away. That's section 3.3 in the books. Thank you.